Hello again. This is part one of getting started with Murder. Specifically, the Murder engine, an ECS game engine built on top of MonoGame. What is Murder? This is the official documentation of Murder that we'll be exploring. Isa and Saint11 have been putting this together for some time to help with their game projects and as a open source piece of software that we can all work with and enjoy. And today we will be building our own player character off of their example. So tutorial number one, setting up the engine, and then the very basics of working with it. If you'd like an in-depth breakdown of many of the different aspects of the engine, please see my previous video. It's a bit long-winded, so this video is intended to be much more concise. What we'll need to get started with the tutorial today is an installation of Git that'll allow us to clone the repository, Visual Studio 2022 with .NET 7.0 support, so desktop development if you're going through the Visual Studio's installer. You just need support for multi-platform development with C# basically. And finally, aseprite, which we'll be using to edit and import, or export, I guess, saving the files to the Murder engine to allow us to work with sprite objects. Now, for everything I show in this tutorial today, it is September 26th as of recording, 2023, is likely to change. So this is a quick video tutorial for people who are much more visual and auditory learners like myself. And we'll be going through step-by-step what to do to get set up. Now, like I said, I won't be going through the install of Git or Visual Studio or aseprite. I'm going to expect that you're able to handle that on your own. First thing we're going to do is get our install folder where we'd like to put the project. I'm going to use git bash just for the sake of being able to easily show it. And so I'm going to open a new git bash here. And then I'm going to clone the repository. And I also need to make sure that I use this command to include or to recurse the submodules that make up the project. There we go. Okay, doing it in real time. I'm trying to avoid copy-pasting anything for this tutorial's purposes. So you'll see everything remote. It will recurse, so it's going to get a whole bunch of different things. So very briefly, it clones the Hello Murder project. That's the main one. And then it clones its first submodule called Murder. So that's actually the Murder base project. It then clones the Bang project, which is the ECS Bang engine. And then it clones Gum. Okay, so here we have the project now cloned. And in the main folder, we can see hellomurder.sln. So this is the main sort of project that's going to contain everything else. Inside the Murder folder, we don't really want to be in here. This is the back end for the engine. So we can edit the Murder engine if we'd like. But really, we want to be in the source folders, because these are our game project folders, really. The Hello Murder is the actual game runtime. So if we want to run this, we can run the game. And the Hello Murder editor is the actual Murder engine editor for our game. If we want to use the editor to make project changes, we can run the editor. And if we just want to run the game, we can just run the game. So to first do that, we're going to open the SLN project, the whole thing. That's going to give us our Visual Studios window here, where we should be able to see, well, at the moment nothing because we have no files open, but on the right hand side we can see there's actually 8 projects included. Under Murder is the Bang Analyzers, Bang Generator, Gum, Murder Editor. We don't need to worry about any of that stuff. The only ones we need to worry about is the Hello Murder and the Hello Murder Editor. Up here at the top, we can also set our runtime projects, so Hello Murder and Hello Murder Editor. Those are the only 2 things we want to worry about. If we're in Hello Murder, we can run that. And as I explained, this will we'll build our game and then run our game in debugging mode. And now we can see we have our little game window. And we can resize this as we so choose. And we can interact with this menu here. If we start the new game, this is what the basic blank game project includes. There's nothing here, there's no interaction, there's no player input. That's the stuff we will be beginning to add, as well as some more sprite stuff. So the only way out of this really is the F5 button there. And so if we now run the Hello Murder editor, we have access to the editor project once that is built. And from within this editor project window, this is where we can access our character, game systems, and our scenes, our worlds. By default, in the Hello World project, this is more than just the absolute standard murder engine editor project, because we have features that are built. So these are predefined sets of systems. There are cleanup systems, physics systems, render systems, character systems, some state machine systems, effects, sounds, and debugs, debug tools, and things like that that are all included as well in the Hello World project. The fonts are the fonts we're going to use for our project and our game. There's nothing in the generated files we need to worry about, but we will take a look at this later when we import an aseprite file to make sure that it's generated correctly. If we look inside the tiles folder, we'll see some of this information here as well. So we can see that there's an atlas that has the checkered floor pattern. We can see that there's this simple tile, and we can see there's also this walls thing. There's not really a lot of information in here that's going to help us at this time. So we'll come back to this once we played around with aseprite and we're ready to bring an actual character into this world. The other thing we're going to just look at quickly inside the worlds is the actual Hello World. And don't QuickTime really right now. The menu. So the menu project, it's this main menu state machine. And you'll see that there's no visual UI for the menu that's pre-built into the project. Unlike something like Unity, which you build your UIs very much with game objects and UI components and things like that. Our menu is currently not built really in any way here. If we play from here or we press F5, we can launch into the game scenes, and it by default launches into the main menu. And then if we press the space bar, we can activate the new game. And again, there's nothing in here. There's no input. There's nothing we can do. Pressing F5 will let us quit that, because otherwise there's no real way to get out of it. And so before we actually get started, I just want to also introduce F1 accesses our console. Tilde is also a way to do the same thing as F5, so go between the game and the editor. And you can see it's amazingly fast to go between, because it's not actually having to build things like building the C# code. It's already compiled, everything's ready to go. It's just hot reloading everything that we basically need to access the game. Continuing there, F2 brings up a whole bunch of debug windows. Now some of them are behind each other, so we kind of need to get them out of the way. But we have a whole bunch of this information here. We have performance, we have the hierarchy, diagnostics, blackboards, which I'm not exactly sure what the blackboards are, and then this strangely empty window, which I assume we will have use of later. We can see in the hierarchy, we have our player. So this is a good way to debug the player. And we can see there's more components in here than we were previously informed about. So if we F5 to quit and we go to the player, we'll see that in the player asset, we have position, collider, and sprite component. The position, it's 0, 0. This is its real-time position in the world. It's transform, if you will. Collider, this is several different kind of layers that we can set the collider on, and different shapes we can also give it. We can also give it multiple colliders if we wish. So we can make a circle collider. We can make its radius anything more than 0. And you can see that our character can have more than one collider, say. If we want to discard the changes and not save what we played around, we can just do that here. Otherwise, we can save the asset And we'll need to remember to save the asset, otherwise our changes will not apply if we close the editor, which sometimes is fine. But yeah, we only have that, and then we also have the sprite component, which right now it's a single static sprite. This is fine for most things that don't actually have animations. You know, it says animation here, but in this case, there is no animation playing with this sprite. We could change this if we want to any other valid sprite. So let's change it to this for now. And that's it. So when we start the game, and we go to our hierarchy, and that's what this window is for. Now that I kind of put that together, we see our sprite, we see our collider, we see our position. So this is our real position, and we can debug it, force this position around. We can see our prefab reference components, which right now, there's nothing really in here, but presumably this will be able to point us to the kind of prefab that we're looking at. A in-camera component, so I believe that this means that this is currently in the full stream of the camera or otherwise rendered to the camera. Animation complete component, which we do have an animation assigned because the dialogue, but if there's no actual animation that's playing, so I'm not exactly sure what this animation complete component is doing right now. It might just be something that's just there to inform us that this frame of the animation is done. But since there's no frame to move on to, we don't have to worry about that. And then is selected component, because I believe, technically, we have selected it. So perhaps that this component is, it's not going to show up if this is not focused. So let's see. Yeah, so if we can focus or release camera, and if we release the camera, or I suppose if we focus, then you can see this is ID target component, it changes. Focus the camera there. So target is 0 or target is 3. So basically the player is number 3 or number 0 and the camera is number 3. What we do want to cover is actually getting our player up and running. So to do that, I'm following a tutorial on Phyto.net/murderengine. So you can also follow along, and I want to give credit where credit's due and let the creator of this be known. So Phyto.net/murderengine, that is sort of the tutorial that we'll mostly be following. There are several ways we can do both animations and player movement. So this is just the way that's kind of set up from how they did their Ludum Dare game example, which I won't be going over again in here. But for now, we're going to do the first step, which is, let me do step 1. Get input from player. So in order to get the input from the player, we need to have some kind of input hook. Now, one way we can do that is by actually going into the MonoGame .cs, which is where the sort of the main class of the game that's running. So this iMurderGame, this is the main loop of the MonoGame. It has callbacks to relevant events within the game. So it has an initialize callback, an update callback, an exit callback, all that kind of stuff. We can also assign a name to the game here. So what we want to do is we want to register our input system. So we're going to go to public void initialize when the game starts. So that's on the initialize. And we're in C# here, in case I didn't explain that before. And there's a few ways we can do this. We can have Gamepad support. So we could have select Gamepad access, and you'll notice that it's added this murder.core.input system here. And we have multiple axes. So we can have, say, Gamepad. gamepad axis dot left thumb, D-pad, right thumb, and that will be referenced as the stick component. So we could say have the left thumb and the D-pad both be referring to the same axis, so that a player can use either the D-pad or the left stick, whichever is more comfortable for them. But if we want a more complicated game where the D-pad does something different from the left stick, then we don't want to do this. And so I'll just finish typing this out just because this is the example from Phyto.net. So it's left thumb and then comma and then gamepad axis dot D-pad. And I've forgotten equal signs here. So the stick equals these things. And finish that off with a full colon, semicolon, I mean. So yeah, we can reference this single stick in order to get our game's input. So if we wanted to do that, we can do game.input.register axes. And then we need something called murder input axis dot movement. And then we'll tell it that it should register both these things, the left thumb and the D-pad, to the stick. Now, as I said before, we don't need to do it this way. We can just do it this way and get rid of that. And now we can use the D-pad for something else. For now, we're just going to register the axes. In fact, let me do that again. Register axes as button. This would be a good way to do the D-pad. It kind of expects us to give it a set of gamepad axes, and it can create buttons related to that axis. So because the D-pad is technically an axis, instead we could have 4 buttons or 8 buttons related to the D-pad, and it will allow us to kind of set it up like that. So that's one way to do that. For now, the one thing I want to do is to register the murder input axis dot movement to the keys, the arrow keys for the keyboard, because we're on keyboard. I don't have a gamepad plugged in right now, so I'm not going to be playing with the gamepad. So what I want to do is I want to assign, say, WASD, and to do that I need to create a new input button axis. So from buttons we're creating an axis, and we need to then define the 4 axes as the 4 keys. So key, and what we need here is to pull the keys from the Microsoft.xna.framework.input. And in case you didn't know what I did there, on Windows I hold Alt and Enter, and I can get this context menu. You don't have to do that. You can also just hover over it and show potential fixes, and then I can get a whole bunch of fixes here. So I can create a method or stuff like that. But actually, I just want to use the Microsoft.xna framework, because that's the C# framework for working with button keys. So I could pull it in like this, but that's really ugly. And so what I really just want to do is just add the using command up here, and then we don't have to type that again. And now I can do keys.a, keys.s, and keys.d. So, that's right. I was not supposed to type register axis. I was just supposed to type register. So game input register. What are we registering? We're registering the input axis movement, not as a gamepad axis, but as a set of buttons. And then we give it the set of buttons that are here. Now this actually does accept multiple params, so we can set another new input button axis, and we could do, keys.up, keys.left, keys.down, and keys.right. So that's if we wanted to have the movement players be able to have WASD movements or up, down, left, right arrow key movements. And again, same thing with the D-pad. It would accept both of these inputs when it was calculating the actual movement parameters. And it could actually accept all 4 of these things, and it tries to figure out what the axis is of combination. Now, something you'll notice right off the bat, if you're used to working with games, especially published games, is that normally we have settings menus, and we allow users to define their input axes and their keys and things like that. So at the moment, these would be like registered defaults, but we probably want a way to actually register the keys, save those to a player profile, load that and unload that and all that kind of stuff. But that's not something that the base Murder Engine gives you out of the box. So this is just kind of the way we can do that out of the box. But otherwise, you could build your own script on top of this and be able to load and save and change keys on the fly with your options menu. But you have to build that yourself out of C#, which is really not too bad. I've done that kind of stuff in Valheim to set custom hotkeys for mods, and so it's really not too bad. Like I said, it's basically just a layer on top of this that you have to build yourself. Because that's a little bit more involved, I'm not going to show that in this tutorial because we're not playing around with options or anything here. So if that's content that you'd like in the future, just let me know. So in a similar vein, on the Phyto.net tutorial, we can see that we can register a whole bunch of other keys for different things. And if we just dig into this a little bit, we can see that we have movement UI and UI tabs. So the base axis, this is the base class for axis constants. Movement is the main one we're going to worry about for the player. But just so it's clear, right now, the UI does automatically work with without us needing to enter anything else, right? If I launch the game, it has to build menu code, of course. So I'm able to navigate with WASD, well, really W and S because there's no left and right to go. And I can also do it with the arrow keys. And something is defining the fact that I can press space here in order to run that. Now, something else that I just noticed there is that I don't have access to any of the editor debug tools because I'm not running in editor mode, I'm running in game mode. So, as I said before, once I start a game, there's no way for me. I'm pressing F1, F2, F3, F4, F5. I have no other access because the editor is not running. I'm not doing the hot reload stuff. I'm just running basically the final game product. And because I don't have a pause menu, I have no way to get out of this other than manually closing the program or ending the runtime. So I don't need to register the UI input access here. One thing I could test to see is if the Gamepad automatically supports the Hello Murder project. And in fact, I might as well do that. So just give me a moment to... No, don't do that. To plug in my controller, and I got the Microsoft logo pop up, but I don't think that showed up on the recording, so that's fine. And if I run the Hello Murder project with my Gamepad plugged in, I am able to navigate about the menu with left stick, with right stick, with the D-pad, and I can even press A to start a new game, and probably I could press start and other buttons. So all that stuff is already also set up out of the box. So I don't need to worry about that right now. If I want to do more complicated things with the UI, or if I want to override any of that stuff, then I can do that. But at the moment, I don't need to worry about that especially for this tutorial where we're just trying to do character movement. So for now, this is all I need to set up in here. I don't have a jump, but I could just register other systems. Instead of registering an input axis, I would register something like an input button. So let's do that quickly. Register input button buttons dot interact. Same thing here. it doesn't know what input buttons are. It's because I need hello murder core. With hello murder core, I can then do this and register an interact key and do something like keys space. So now I registered the spacebar key as this other interact key. And if I go into here, I can see some things that are added by default. Now, skills 1 through 4, not every game is going to have skills in this way. Not every game is going to have level up in this way. So some of this stuff is definitely what I would call legacy, or stuff that they had from their like temporary projects that's made it into this kind of hello murder game, just as examples of how you can set things up. So you're free to change any of this. It doesn't have to be called pick. It doesn't have to be called lock movement. This could be a dash, sitting and attacking. These are all things we can just change around to give us any kind of input that we want. And we'll talk about how we read the input in a little bit. What we may not have to do here, though, is actually playing around with the input system, because the next thing we're going to do is we're pretty much done with the Hello Murder game. So let me just state that clearly. So we're pretty much done with this Hello Murder game CS right now for what we need to do. And the next thing we're going to do is we're going to modify the input system, take a look at that code, and make sure that everything in there is stuff that we actually want to use. So to do that, we're going to have to go to the player input system .cs. And we're going to see that this is starting to get a little bit more complicated because there's a little bit more stuff predefined in here. For example, we have the player input system, which has a filter of contexts, and it's going to look for player components and agent components. So if it finds something that has player and agent, then it's going to utilize this player input system. And it's a iUpdate system, which means it's going to be updatable once each frame. And it's also a fixed update system, which means it can be called on a fixed interval. So it has both of these capabilities. It has some private variables here. In here, there's, for example, these cached input skills. We don't really care about cached input skills. We're not using cached input skills. And we're not even using cached attack and all this kind of stuff. So none of this stuff really matters for what we want. All that we really want is the cached input axis. We're just going to see if it has any kind of value in it, and then we're going to get its direction from its vector with this nice little direction helper that they give us here. And then the game is going to set the impulse value on the entity, and that comes from basically from the direction that it's setting. What we can basically do is just just get rid of that, and we can really just wrong button. Control K, Control C, and like none of this stuff matters, so we don't care. So all we're really going to do in here is move it. We don't even need this interacting thing either, because entity is not going to interact with stuff right now. We're not going to be able to pick things up off the ground. So same thing. We'll just get rid of that, make it a little bit more basic and easier for us to understand what's happening. And then in our actual update, this is how it's going to pull the information from the input system that we registered our axes to. So we registered the axes to, we registered buttons to, and it's going to do all this sort of stuff. So in Faito's example, he registers all of these commands in all of these systems, but we don't have any of these systems yet. We don't need these. We don't know what these are. So we're just gonna remove them for now, because these things updating don't matter. Obviously, that's going to create a thing where all of this stuff is not being used, and that's fine. In fact, let's do that. Let's clean this right up and see what it looks like after that. Because now this is a pretty easy player input system to manage, right? It's not overwhelming. We know what every single piece of this does. We don't actually need to fetch this player component at all. So even easier. There's a whole bunch of other stuff up here that we don't need anymore, like geometry and state machines. We can get rid of all those. So we have a pretty clean piece of code, and now we are ready to get back into the game and start actually adding some of this stuff to a, well, in this case, it will be a player and an agent that we can set up. So to do that, we're going to leave Visual Studios for a moment. We're going to go back into our actual Hello Murder editor. So again, that's our game editor for working with and building out our game. And hey, look, the last thing I had open was the character, the player prefab, and this is pretty much where we can work out of. In a moment, we will also be going over how to add sprites and animations and all that kind of stuff. But before we get there, let's just have a non-animated static sprite basically moving around in the world. And so in order to do that, we should be able to add our player component and save it. And let's just for a moment see what happens if we run the game. Well, we don't have any movement. Even though we have a player component, even though we have this thing set as an actor, we're not quite done. We have to make sure that the world is actually going to listen to our player input system. Because as we said, the player input system is specifically for controlling like a character with the WASD and all that. And of course, the game engine doesn't know that that's how we want to play the game. Maybe we don't need to control a specific character. Maybe we're going to be navigating menus and we're going to be giving commands to units and the units are going to move on their own or whatever. So in order for the game to know that we actually are going to have a player input system, it has to be added to the systems that are running in the world. The player input system needs to be one of these. And by default, it's not. If we go into the game systems, we can see that this is that big list that we saw in the world. So that's this list, game systems, features, game systems, and this is features, game systems. However, there are more sections in here. There's cleanup, there's physics, render, character, state machines, effects, sounds, and debug. And so in order to get our player input system in here, we want to add it into the right place so that it will act according to the order of operations here. So just to get ahead, the correct place to add this is inside the character. And so we can go into the character feature and we can see that we have pathfinding and calculate pathfinding. So if we were to change the order of these things, it might break because it might try to pathfind before it has calculated the pathfind. So we need that to stay at the same order. We can add a system in here, which is the player input system. If we save this, we go back to our game systems list, we can see that this characters section now has pathfinding root system, calculate pathfinding system, and player input system. So it will now use our player input system. And the reason that this needs to be here and not, say, added here, actually, it won't even let me add it because it would be a duplicate of one that already exists. Let's say I just added my cursor system here. The reason I can't add it here in the world is because these systems are all going to run. And then, this world system is going to run, or this world system is going to run, and then all these systems are going to run, whatever the order may be. And we can't have, say, the agent cleanup system run between our player input system and our physics agent move system or agent mover system. If the agent cleanup system runs, well, let's see what it does in code. Whatever. The agent cleanup system has its fixed update where it will get all the agents, all the entities, and it will try to see if it has an impulse. Remember, we set the impulse in the player input system. Here we set a agent impulse. And this is going to try and check if it has an impulse. If it has an impulse, it's either going to set the friction or it's going to remove the impulse. And impulse, of course, is like a type of physics movement where it's physically driven and it has acceleration and deceleration and all that. So if we remove the impulse before we've applied the impulse with the agent mover system, I think, where it does this impulse to velocity, it gets the agents, it gets the entities, it gets the impulses, and then checks, that it has a value, and then actually like gets the velocity and sets the velocity. If we end up getting agent cleanup system called first, then we will not be able to set any velocity because we won't have an impulse anymore. So that's why we need to make sure that where our systems are actually going, the location that our systems are running in, the order in which the systems are running is quite important. So the player input system is going to run, and our agent mover is going to run, and our agent cleanup is going to run. And in that order, everything works out just fine. So I need to make sure that I have player input system here, and it looks like I do. I can make sure everything is nice and saved. So this is a player component. This may not be enough. It may need an agent component, but let's just see. And yeah, so even though we're probably getting input, we're not able to move just yet. So if we add an agent component, we can see our agent component is actually what's going to define our speeds. So we have speed, acceleration, and friction. If we jack the friction all the way up, then that's only going to apply when we're not pressing on the keys, because our like movement is only, it's frictionless basically, which might not be what you want, but for this example, this is fine. So if we set an agent on it, and it's a player, and it has a collider and all that kind of stuff, let's see now. Boom. Now we have something that moves. And it does move with a little bit of, what would I call that? Slide, icy physicsness. If I release my key, it stops immediately. But if I'm going in one direction and I'm still holding the keys and I try to go in another direction, I don't turn instantly. What I can try to do is see if setting the acceleration equal to the speed is going to make it instant acceleration or not. Maybe. So it's not perfect. There's still a little bit of iciness, so I might want to make the acceleration a little bit higher, but it's definitely much closer to how I would sort of expect it to work. And I could play around with this to my heart's content. All right, so that is getting a player moving with basic input, extremely basic. I don't think the next part will take a long time, because the next part is aseprite's animations. And the most important element of the aseprite animations is actual sprite creation and how it's set up to work with the Hello Murder editor, for example. First thing I'm going to want to do is open up aseprite. And I'm going to show you this example. Now, I do apologize if this is not how you're used to seeing aseprite. I have a theme on it. So if you're familiar with aseprite, this shouldn't be anything too complicated for you. One way to set up the sprites that works a little bit easier for aseprite is to have a single 32 by 32 or 16 by 16 or 64 by 64, whatever. Have your single character in a single sprite box and have each of its frames on different keyframes. And then you can combine the keyframes with tags. So having a tag on an animation, I can set this animation. And the thing I want to keep in mind for at least the way we're going to do this first kind of sprite is the prefix and the suffix. So the prefix is something like walk underscore or idle underscore, and then the suffix is something like, north, northeast, east, south, southeast. And we can even do southwest and northwest and west if we want. The reason I've done it this way, to have north, northeast, east, southeast, south, is because for the northeast, east, and southeast, we can just flip the sprite. For this kind of sprite, which is all black. It doesn't have any lighting information on it. If you have a more complicated game and you are drawing lighting right into your sprite, then you probably don't want to just flip the sprite. Or if you have a sprite that has a weapon or an item and it always carries that in its right hand, then again, you probably just don't want to flip the sprite because it's not symmetrical. So those are just things you need to keep in mind. When we save this, we can save this inside our game project. More easily, we can save it inside the resources folder in here. And we could create a new folder, call it characters. And if we save it into here, we want to make sure that we're saving as the raw aseprite file, because that's how the engine is actually going to use it. Now, if I've done this correctly, what I should be able to do is reload content and atlases. And inside the generated folder, there is now a folder called character, and there's a JSON object data for the sprite asset of the shadow clone sheep zoo thing that I made. And each of the elements in the atlas are actually the different parts of the sheep. If I go to the atlas page, I can see that in the atlas there is this walls icon, walls item, tiles, simple tiles, and there's all my sheep and sheep animations. And that is because it had to take all the elements of the sprite from aseprite and put it into the atlas. And now it can access each of these by its index. But when it's referring to the actual aseprite, it's just a single thing. It's a single file, right? It's a single file with a whole bunch of animations in it. So that's what this is. Yes, the atlas has them all laid out for efficiency, and so it doesn't have to decompile the aseprite all the time. But now the interesting thing is, if we want to muck about with our player, one thing I'll do here is I will right-click duplicate on the player. So we'll have our original player here. I got to save this asset, because even though I just created it, it's not automatically saved. And then in this player, I can actually start to add the animations in. And there's a couple ways to do that as well. The way that Phyto does it is to add an agent sprite component. So we have an agent component, and we have a sprite component. If we say got rid of the sprite component, we can add an agent sprite component, and then we can select an animation set to be more specifically. And in here somewhere should be our sheep character / shadow clone sheep zoo. There we go. Now it doesn't know what animation to play or how to play it, so I need to make sure that all these settings are correct. So I don't need to worry about the Y sort right now. I might need to in a bit though when I go to test it. The idle prefix needs to include the underscore, and the walk prefix needs to also include the underscore. And then the flip west button can be checked because we want to flip the asset for the west thing. So the suffixes, starting with 0 going clockwise, east, southeast, south, southeast again, east again, northeast, north, northeast. And that is because northeast, east, southeast, those are flipped when facing west, so we don't need to include west. However, if, like I said before, we had a sprite that had lighting data for facing west, since this is starting at 0 going clockwise, we would need this to be southwest, this to be west, and this to be northwest. and we would need to have 8 directional animations. I can also set its facing direction, so I could face it in different directions, and I can also make sure that all of these look correctly. So for example, if I had this as southwest, and I actually it would be this at southwest, there we go, then you can see it's empty because there is no idle underscore SW. There's only idle underscore SE. If I face it down right, it's looking that way. Okay, and I want to make sure that this is saved. The last thing I was talking about, the agent sprite component, we don't need to use the agent sprite component. We probably want to build on the agent sprite component. I mentioned about the southwest, southeast sort of thing that we can all do, but we may not want to use the flip west and all that kind of stuff. Now, going back into the world, because we had this player here, the player it was our old player, and we just needed to like basically discard our changes so that it resets the player to the updated value, because we can make player changes in here. This is an instance of the player. So let's just do something simple. Let's set this friction all the way down to 0, save this asset, and play the game. So we have no friction anymore. And if we go to our player, we can check its agent component, and it still has friction. So these act as sort of overrides because they are instances. So you do just need to be careful that if you do create an instance, that the instance is not modified here unless you are aware that you're modifying it here. Now, I did have to kind of redo some footage here, so I have changed some things, and I just want to go over that briefly. Number one, I did change the collider in order to make it a little bit more realistic with how it interacts with the world for this kind of player shape. It's not a requirement. It's really just based on how you want your character to react, say. And the way I did this is I basically took this sprite and I just set the collider. In fact, I can even drag out the collider from here. And I just made it kind of match this shape so that the bottom of the collider should be the bottom of its legs. The top of the collider doesn't need to necessarily be its head, because I'm okay with, say, when it's facing upwards, if the top half of its body is overlapping something that it's standing over or it's standing in front of. And just to show you what that looks like. So here we have this wall on the right hand side, and we also have this overhang on the bottom side because this is sort of an isometric style art. And then we have this front facing of the wall. So what I expect when I'm running into the wall is that I basically run up right to the wall. When I go under this overhang, I should be hidden. And when I run up to a wall, I should sort of stop where my legs would hit the wall, or where my body from this angle, like my nose is touching the wall, somewhere at the halfway point up the wall, or a little bit above it. And that just contributes to an overall more realistic feel based on this art style. Now, it's really going to depend on the art style. Again, you might not even use the 8-directional kind of sprite system to set up the game. If you just want to have, 2D platformer kind of movement, then this will work as well, but you won't need the 8-directional movement in that case, so you won't need this kind of agent sprite component to do what it's doing here. So playing around with our collider and how that's going to act, playing around with our agent, changing the friction and the acceleration so that it moves in a way that we enjoy. And that's pretty much all we have to worry about. There's nothing in the player component. That's just to let the game know, the system know, that it is a player. And the collider, I think as I showed this before, we can have multiple colliders, things like that. And so that's all we really need to worry about. Now, you'll notice this here. This lets us pick new entities to throw into the world, new instances of this object. And say I have this many player objects. I have 3 players. I should expect, yeah, that I can control them all. So maybe I create a kind of puzzle game where I have to figure out in this level or in this just game, I don't know, maybe I have to get them all to overlap, and I can do something like this. Now they're all overlap. They're not perfectly overlap. I could probably get them to perfectly overlap. And I'm not exactly sure what the Z. I probably don't want their Y offsets to all be the same. That might be the cause of this flickering, or could be the cause that their animations are slightly off sync by like a frame or something like that. I'm not exactly sure, but I'm sure those are issues that we could address. A little bit of experimentation. Yeah, so I don't want that to actually be saved, so it looks like there's not a good way for me to do this other than just deleting these extra assets. And that's about it. That's all for our player setup. Now, I did also expand sort of the written steps in case you'd like to see those as well. So number 1, we got the input from the player. We defined our inputs in our script. We defined the keys that we're registering with the game's input system. We applied the input to the entity. Now that was kind of already handled for us, but we just ripped out all the extra code that we didn't need. We needed to then add the components to the player prefab so that it actually knows that it's an agent and it has a player component on it. And then we needed to add the player input system to the game features to make sure that the world actually had the player input system that it was running. It was listening to the player inputs. And finally, we set up the actual sprites and the sprite animations and the directional animations from our aseprite project so that our little animation here will play in the game as we see it within aseprite. So with all those things done, I would say that this video is complete. It is a free and open source software, so please feel free to check out the GitHub page. The documentation is here with a lot of information that's all getting filled out. A lot of the actual like types and all that kind of stuff is here. Some explanation of these things, and it's building up more and more. You can also join the Discord, and you can just be part of the community. Check it out. Help out if you'd like to contribute, things like that. Otherwise, you can use it. I think we were at like 70 something members. Now we're at 80 already, just by the time I joined. And I'm not a founder or even a developer of the engine, anything like that. So it's pretty cool, and it's getting big, and it has some really, really awesome stuff that being able to put together like a whole game scene like this and have like, yeah, buffs, chest, crafting, email features, all the features that you have, like the global events. Oh, that would be really cool. Global events, monsters, NPCs, particles, skills, all this kind of stuff that kind of explored some of these elements that they had in the Ludum Dare project. But of course, they have even more awesome things here. So I hope to eventually be able to dig around in one of these other cool big projects. Until then, do feel free to put a comment in the comments, or put a question or anything else you'd like to explore next time. I think next time what I probably will be doing is something like exploring an enemy, which is probably going to be pretty much identical to the player. I might create a custom component, like a health component for the player and a damaging component for the enemy. And I might have a health component for the enemy as well. And have, say, a very simple kind of enemy that if it walks into you, it damages you. And if you take too much damage, then you die. And so that's one kind of thing I want to explore, is like the interaction between components. Another thing I might want to explore is actually the UI and setting up the UI. And then another thing I think I want to explore is the tile sets. So in fact, let's add that here, so it's on our list. So next, player and enemy interactions. game UI, and tiles, well, environment tile sets. Figure out how those things work. Let's call it making components and systems. So these are probably the things I will plan to learn and then make a similar like video to next. Till then, thank you very much for watching. Take care.